Hi there, this is GCSE Electricity and this is lesson 4 and this is IV characteristics of a fixed resistor. The objectives are to explain how we set up the experiment for measuring the IV characteristics of a fixed resistor and then to be able to draw the IV graph of a fixed resistor. And we'll also do an exam style question. So first of all, we're going to look at the circuit diagram and the procedure. So I'll try to do this as neat as possible. So first of all, we need a power supply. Just make sure that that screen won't move. So power supply. And then we need a variable resistor. So it'll look something like this. And then we need to go into an ammeter because we need to be able to measure the current. So into an ammeter in series. Then we need to look at the component. So I'll put that component here. So this is the fixed resistor. So we're looking at the IV characteristics. So we've got the current dealt with. Let me just connect the circuit back up. So you can be asked to draw this in an exam, and I would draw it literally like that. You can connect them up if you wish. Then we need a voltmeter across or in parallel with the component that we're looking at. So something like this. And that can be worth 3 marks. Okay. If you want, you can put a switch in there, but it's completely up to you. That'd be fine. The current will flow that way from the positive side of the battery. So now we can measure the current using the ammeter and the voltage using the voltmeter across the resistor. Then what you need to do is select the values that we're going to use for the experiment for the voltage. So we're going to need a table. Let's just sketch a little table. And we're going to need the current measured in amps and the voltage measured in volts. Now typically for a resistor, depending on the value of the resistance, you might go between say +6 and -6 volts. So +6, 5, 4, to 0, and then go the other way, -1, -2, -3, until you get to -6. So what you would do, you would change that voltage using the power supply. So you'll either have a power supply, which is like might be a blue box or something, or you'd have a variable resistor set up at school. So you could change the voltage and then measure the current, and what you would do is write the current for each thing. Now, what I'm going to do is just talk about variables for a moment. So there's 2 types of variables that we can talk about for this one. You've got the independent variable. And the independent variable is what we change. What we change. And then we've got the dependent variable. Dependent variable, and that is what we measure. You can write all this down if you want. So, in terms of what we're changing and what we're measuring, we are changing the voltage and we are measuring the current. So you could be asked that in an exam. Another thing is at GCSE, when you plot a graph, you should always plot within reason. The independent variable on the x-axis and the dependent variable, I'll just write depend, on the y-axis. So that's some more information. So we've got the range, +6 to -6 volts. If it asks you in the exam to describe the experiment, how you would set it up, you want to be saying, the range of voltages, measure the current, and then we're going to plot a graph, and I'm going to show you what the graph looks like now and what we can find from it. So this is the IV graph. So we've got current against voltage. Remember, this is the independent, and the independent variable in the experiment was the voltage, otherwise known as the potential difference. And on the y-axis, we've got the current, which is the dependent variable. So this is called an IV graph because current is I and voltage is V. You should also have the units on the axis. So like that. So current in amps, voltage in volts. And what you get when you do this experiment, you should get a nice straight line. And what that tells us is that the current is directly proportional to the voltage. So I'm going to write this directly proportional to the voltage. So that means basically is that if we double the voltage, we should get double the current. If we triple the voltage, we should get triple the current. And you also get the same, so this section, this bit, can be called forward bias. And this is reverse bias. Now the way that you get the negative results is you literally grab the cables that go into the power supply and just turn them around. That's reverse bias. And they're the same. And because the current is proportional to voltage, we call this device, because it's a straight line, we say that it's ohmic. And what ohmic means is that it obeys Ohm's law, which is from the previous lesson. So this obeys Ohm's law, and Ohm's law, if you want to remember, is V equals I times R. So there's something that we can get from this graph, and I'm going to show you right now. So from this graph we can get a gradient. So let's just make some numbers up. Let's say that this is 1 amp and this is 10 volts. And what you do, you take the gradient, change in y, change in x. So the change in y divided by the change in x. So the change in y in this instance is simply 1 amp, divided by the change in x, which is 10 volts. Obviously, we just made these numbers up. So that gradient, 1 divided by 10, the gradient is equal to 0.1. Now, what we can get from this, if we do the inverse of the gradient, so that would be 1 divided by 0.1, we get a value of 10. And that would be the resistance of the device. So from a current voltage graph, if you do the inverse, if you do the gradient and then do 1 divided by the gradient, you get the resistance. That's the official way of doing it. You could just look at the values. So in this instance, we've got the 10 volts and the 1 amp, and Ohm's law is simply voltage divided by current, so 10 volts divided by 1 amp, which will give you the 10 ohms. So if you spot that, I suppose we can do that one as well. Right, hopefully that's helped. Hopefully you've got a, you can draw the circuit diagram. You know what kind of results you should be taking for your table. And you know what the graph should look like once you've done the experiment. And you also have got some information about it being ohmic, what the variables are, and what you can get from the gradient, etc. So what we can do now is finish off with an exam style question, which I'll put up now. So if you want to have a go at this one, so this might be a 6-mark question, so you really ideally might want 6 points. And then I'll put the answers on now. So switch the circuit on when required, and switch off in between readings to ensure it doesn't heat up. So that's a point that we haven't really covered, but we have now. So we're going to alter the variable resistor and our voltage values across the resistor between -6 volts to +6 volts, and measure in 1 volt increments. So we talked about that one. Measure the current for each voltage reading. We discussed that, especially with the table. Then plot a graph of current on the y-axis against voltage on the x-axis. That's another point you could make. You should get a straight line that goes through the origin. And take the gradient of the graph and do 1 over the gradient to get the resistance. So that's an example of a 6-mark response to a question like this. Anyway, I hope that's helped. Thanks for watching. I'll see you soon.